Laplace transformation. Today is the first session of Laplace transformation. So today we are going to cover some basic related to Laplace. So Laplace transformation session 1. Laplace is denoted by capital L and factor of Laplace is denoted by L. You can use curly bracket f of t, or you can use simple bracket Laplace of factor f of t. You can use curly bracket or you can use simple bracket. It's up to you. Means Laplace is denoted by L. Factor of Laplace is denoted by either this way or this way. And Laplace is made up of three things. Means Laplace equation is based on three things. First is integral, second exponential, third is factor. Means Laplace equation is made up of three things. First integral, second exponential, and third is factor. So what we have, the equation of Laplace is Laplace f of t is equal to integration 0 to infinity e raised to minus st f of t dt. Now, first is integral, second is exponential, and is factor. Now, we can see the factor f of t, whatever factor f of t is outside, the same f of t inside. Means first two value means integral and exponential are fixed term. Only thing is that f of t will be variable. Means if of t is x, then we will use f of t as x. If f of t is sine 80, we will use sine 80. If it is a cos, it's cos, etc., etc., etc. So it's up to the what the value we have to derive. Now, Laplace, the equation of Laplace is this one, but Laplace is also denoted by Laplace f of t is equal to f bar of s. Means Laplace is denoted by either this way or this way. You can use any, but you keep remember both both these two formula, because in upcoming sessions we are going to use both of these formulas. So this is a basic. Now based on based on this equation, what equation we have? Laplace f of t equal to integration 0 to e raised to minus st f of t dt. This is the standard equation of the Laplace. And based on this equation, we are going to derive seven basic terms or values from the Laplaces. Seven values. It's a basic, and these basic terms are we are using in upcoming sessions. This value are really important for us to solve the problems. Now, what are those seven formulas which we need to derive by using this Laplace equation? First, Laplace of 1. Second, Laplace of e raised to 80. Third, Laplace of sine 80. Then Laplace of cos 80. Point 5. Laplace of sine hyperbolic 80. 6. Laplace of cos hyperbolic 80. And 7. Laplace of e raised to n. These are the seven formulas which we need to derive in upcoming session as well. But today we are going to have a discussion on first three. If it is, if I get some time, I can also cover fifth one, sorry, fourth one. But we will completely focus today on first three formulas now. First, Laplace of question mark. What is the value of Laplace of one? Now, what we have Laplace of Laplace of sorry Laplace of t is equal to integration 0 to minus to st f of t dt. Now, what we are going to use? Okay, now you can see here we have to derive value of 1 means factor is 1. So we are going to use 1 as a factor in the place of f of t. So Laplace f of Laplace of equal to 0 to infinity raised to minus st 1 t. If we simplify this 0 to infinity raised to minus dt. Now integration of exponential factor is we had learned this basics in our 11th and 12th standard. So we will integrate e raised to minus st. So e raised to minus st on minus s limit 0 to infinity. This is the basic formula or standard formula for exponential, means integration of e raised to minus st will be e raised to minus st upon minus s, because constant is minus s. If it is only s, we will use s. Now in this case we have minus sign attached to constant s. So we have to very careful on sign as well. Now I will take this here. Okay, what we have equal to Laplace of 1 0 to infinity, sorry, e raised to minus st upon minus 0 to t. Now we will put this limit in this equation of e raised to minus t upon s, e raised to minus s into t s minus e raised to minus s into 0 upon minus s. Okay, now e raised to minus s into infinity. Infinity into anything will be infinity only upon minus s minus e raised to 0 multiplied by anything will be 0. Now no need to put minus n or plus n because 0 doesn't have any sign on minus s. Now equal to, we have some standard values. E raised to minus infinity is 0 and e raised to 0 is 1. So we have to use this value because these are the standard values. So there is no any rocket science. We just use that to values. E raised to minus infinity 0 upon minus s minus e raised to 0 1 upon minus s. Now 0 upon minus s 0. Now this minus and this minus become plus 1 upon, means what we have derived Laplace of 1 is equal to 1 upon s, means the value of 1 will be 1 upon s. This is the first equation which we have derived. Now in comment box if you have any doubt related to Laplace of 1, please comment me so that I can able to give more clarification if you need it. Now second, Laplace of e raised to, second, Laplace of e raised to 80. We have Laplace of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. Now here factor is e raised to 80, so we will using same Laplace of e raised to 80 equal to 0 to integration 0 to infinity e raised to minus st e raised to 80 dt. In 11th and 12th, we learned that when we have the common base, we can add the values which are in k raised to x to e raised to y is equal to e raised to x plus y. So we can make the common base and we can add the value which are in x. So similar way we are going to utilize this formula 0 to infinity e raised to minus st plus 80 to dt. Now 0 to infinity will take t as a common, so e raised to minus s a into t dt. If we also minus adds common, hence minus s minus a to t dt. If you take the minus common, the value will not change. If you multiply minus in the bracket, minus s you will get as it is minus into minus plus a. So we are getting this as it is value. So no need to worry about that. Now we in last um, equation means in last derivation of this we derive the value of Laplace 1 and we had used the formula of this integration of exponential values. We are going to use the same formula here again. E raised to going to use the same formula which we had used in last e raised to minus s minus a t d2. So we have the standard equation or standard formula for this. So e raised to minus s minus a t on minus s minus a 0 to t. So we are going to put this limit value inside the bracket e raised to minus s minus a to infinity on minus s minus a minus e raised to minus a into 0 upon minus s minus a. So anything into infinity will be infinity minus s minus a. Anything into 0, 0. No need to put minus sign because 0 doesn't have plus or minus. Minus s minus a. In last equation we already discussed e raised to minus infinity 0 raised to sorry a raised to 0 is equal to 1 0 upon minus s minus a minus 1 on minus s minus a. Now minus minus become plus 0 plus 1 upon s minus a. So Laplace of e raised to at is 1 upon s minus a. And last, we discussed Laplace of 1 is 1 upon s, and now we had discussed Laplace of a raised to at is 1 upon s minus a. Now, till now we had discussed Laplace of 1 and Laplace of e raised to at. Now, third equation we are going to derive the Laplace of a. Third, Laplace of sine 80. What we have? We have the Laplace of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. We have this standard formula. Now the factor value is s of s, sorry, sine 80. So you are going to use Laplace of sine 80 integration 0 to infinity e raised to st f of, sorry, are using into sine 80 dt. So again, we are going to use some basic formula which we had learned in 11th and 12th standard. In 11th and 12th, we learned one formula, integration of e raised to x sine bx is equal to e raised to ax upon a square plus b square into a sine bx minus b cos bx. So in 11th and 12th, we had gone through this formula. Integration of e raised to ax sine bx is equal to e raised to ax upon a square plus b square into a into sine bx minus b into cos bx. So we are going to apply the same formula in this equation, but the value which we have are slightly different. Here we have a is equal to minus s and b is equal to, we have a. So what we will get equal to a raised to minus st upon a square means minus s square plus b a square into a sin bx. Now we will get a means minus plus sine 80 minus b means a into cos 80 0 to infinity, the limit which we have 0 to infinity. Now just simple steps, no need to stress anything on what we did. So simple integration of e raised to ax sin bx. We have the standard formula. We use the same formula in our equation. Only thing is we have constant a is equal to minus s and b is equal to a. That's it. And we apply the same logic in this formula. Now we are going to solve this. Okay. We are going to use limit now e raised to minus s into infinity upon minus s square plus s square minus s sin 8 minus cos 80 minus e raised to minus s into 0 upon x square plus s square minus s into sin 0 minus a cos 0. Here, made a mistake. I have to use a into infinity, sin a into infinity, cos a into infinity, because the value of t is infinity. So, let's correct that. Is equal. Now we are going to use the same logic which we had used in previous equations. E raised to minus s into infinity. Anything into infinity will be the infinity. So, e raised to minus infinity. I will use the same for square plus square minus s sine infinity minus a cos infinity minus this to 0 square plus s sine 0 a cos 0. Now, e raised to minus infinity 0, sine infinity indefinite. These terms are indefinite, so we cannot have the value for sine infinity, so it's indefinite. 1 s square plus s square into minus s sine infinity minus a cos infinity minus this to 0 on square plus square minus s sine 0 cos 0. 0 upon anything 0 and 0 into anything 0 minus e raised to 0 1 square plus square into minus sin 0 value 0 so a cos 0 value 1. Now 1 minus 1 upon s square plus s square s into 0 0 minus a. Now 0 and minus a minus minus become plus square plus a square means Laplace of sine 88 on square square. So this is the value of sine 80. So in today's session we learned Laplace of 1 is equal to 1 upon s. Laplace of e raised to 80 is 1 upon s minus a, and Laplace of sine 80 a upon s square plus a square. So next session we are going to cover rest of the values. So if you have any doubts or anything, you can comment me in the comment box so I can able to clear your doubts. Thank you all.